in general, electronic devices are not secure. I think we all know this. I don't mean step on any InfoSec people's toes, but they're just not secure. Everybody in this room has a smartphone. Yeah, I call it my spy device. I'm not the only one to call it that. They're not secure. That feel that privacy is not that important anymore. Who needs it? I don't care if somebody knows my heart rate or my temperature. If my temperature goes up and I'm a COVID risk or an influenza risk, like that's okay. I'm going to stay home. Maybe somebody tells me to stay home, and that's good because I didn't know. It's all good. However, it turns out, even though that's what you might feel is true by just talking casually to people, when people are polled and explained explicitly what kind of information is being released, 95% of people polled do not want their medical data released. They want it private. So people, in fact, do want privacy, and they do understand, when it's explained to them, they do feel and understand that they don't want to share that data, which makes total sense to me. There's been studies done over and over, so let's just say that that's an understood thing. So people possess various levels of privacy, just to kind of break it out. They possess bodily privacy, as well as personal information, financial, right, territorial, so the drone doesn't come and look at you, communication privacy, which we all have lost because of the smartphones. But bodily privacy, for the first time in history, it can be accessed by medical devices. Medical devices, they might surprise you, include Fitbits, smartphone apps, and maybe it doesn't surprise you, retinal implants, which have been around since I think 2009, getting better all the time. They now have wireless communication with retinal implants, and they can upload data to it. That's very interesting. Wireless blood pressure machines, right? Genome tests, you might not think of that as a medical device, but it falls under the corpus of the data that's provided, personal health information. TSA body scans, not intended as a medical device, but they can tell your weight, they can tell your height, they can tell your gait, they can tell a lot of information from a TSA body scan, and guaranteed they do not delete those things. The collection of data from your daily activities, when you walk, when you run, when you bike, when you sit, how fast you type, that's a biometric information that's collected when you're on your smartphone. May not seem like a big deal, okay. Over time, your typing rate may change, and that may indicate a mental health problem or an aging acceleration. So, and you may not want that information out. That's too bad, because it's going to be out. Without your permission, with or without your permission. Your eye motions, how do you track what you're seeing on the screen? That's collected. Your sleeping patterns, we all know that's collected because your phone politely goes off at night and perks up again in the morning. Personally, I think this is too much information, but let's keep talking. All of these may be combined with each other and correlated to come to very surprising conclusions, and combined with health data from all other medical devices. So that's something. So again, about your privacy. So here's an example. This surprised me. I hope that you guys find this a little surprising. Not too surprising, Google bought Fitbit. Okay, they paid $2.something billion for it. Must have some value, your walking data, right? Well, who cares? Okay, so now they have Fitbit. So they own all that data, your data, and then they went out and bought the electronic health record company Ascension. This should really irritate everyone in the room and everyone listening to this talk. They bought your electronic health records, your private health records that we were assured when this program started would remain private. Your conversations with your doctor, your interactions with your physician, all your medical health data, whatever you tell them, whatever prescription, everything, that what you tell your doctor not only isn't private, it's been sold. And it's been sold on this massive scale. It's been sold to Google, it's been sold to Amazon, it's been sold to Facebook. It's gone. It's gone. I mean, it's gone. Now, some of you might feel, well, it's probably anonymized. We'll talk about that in 1 second. So, so here's a fun fact. 5 days of walking data from a Fitbit or any walking app, they don't have to be contiguous. So just 5 days of your walking data can be used, that data, to uniquely identify you from a medical database of over 100 million individuals, 100 million individuals of anonymized data. So you take your little Fitbit, your gait, however you walk around, and they pull out your entire medical health record from an anonymized database. That's just one thing. right? There's lots of data out there. This is just walking data. Google, in addition to that, Google publishes research regularly on how they can use the apps that they collect from your smartphone. We're not even talking about hacking or medical devices yet. We're just talking about medical information. They have ways that they count as reliable, and they're published, and physicians agree with them. I don't know if I do. I don't know if you're going to after you hear this. They can take your walking gait and say that they can predict that if you will or will not have Alzheimer's. That's weird, in my opinion. They can say whether or not you're depressed or whether you have any mental health issues. Again, this might sound really good, but think about what if they make a mistake? Are we all reading in the news now that this has nothing to do with medical devices, but the serotonin reuptake inhibitors, the antidepressants that have been on the market for decades, now are being shown like, oh my God, it looks like depression doesn't have anything to do with a problem with serotonin reuptake. Too bad, we've been prescribing all this time. So there are mistakes made in medical diagnoses, mistakes that the whole field will make for decades, and then somebody will say, oh no, this is a new paradigm now. So what if Google has an algorithm that is accepted by everyone that says you have mental health disease, and furthermore, for public safety, you have to have this medication, which we put little RFID tags in so we know whether you've taken it. You're going to have to show us that you've taken it because for your neighbor or for the community or to reduce everybody's health costs because we're all covered by insurance. I find this to be a highly invasive problem that I don't think enough people are aware of. So I hope I've drawn a picture that makes some of you say, is this okay? Is this socially okay? Do I feel good about this? Maybe you can't tell, but I'm not a fan.
I don't.
Yes. So there's medical devices that we're going to say more about, and the ones that are implanted. Well, they have unique IDs, like your phone. And here's the information that is freely broadcast by these devices when they're used, by everyone who has any kind of medical implant. That's a box.
No, it's actually showing
Okay.
its information.
Yes.
You
Yeah, it's on the...
If you wanted to then.
This number is on the side. Everyone has unique information. Your name, your physical address, your date of birth, your social security number with every transmission, boom, all over the world, wherever it goes on the internet, social security number, along with your name and physical address, your date of birth, email address, date and location of the data collection. So if you're moving around, it doesn't have a GPS. It'll triangulate from the towers that you're communicating with. Your phone number, your fax number, your medical chart identifier, which is a unique number, your physician and or hospital, medical insurance carrier, the IP address that the information, like a ping information, how it was transmitted, the unique identifier of the medical device and its serial number and its software version, and the data communication path or tower ID. That's just normal. That's just what they send out. That's a lot of information. I don't normally even send out my social security number in like email or text. I mean, I hope nobody in this room does. But that's by itself, and I don't like to disclose that. So now this whole corpus of information. That's just the header. That's just the header. Then there's the payload of the actual medical information. So Jim is not dead, but your security may be, and this is the security of the device is what I meant by that. So it turns out that these have been studied, and probably many people in the room, because people have been chatting with me for 2 days now about this, a lot of people are aware of the different flaws in different devices. There's not a medical device out there that doesn't have a security flaw. Boom. Okay, done. So they all have these security flaws, and there's tons of legal cases. I mean, I have some references embedded in my talk. I'm happy to share the slides, but all you have to do is take a phrase and Google it. It's like not a secret. So they have tons of security flaws. There's tons of legal cases. Google's been sued for leaking data. I don't even think they've had it for more than 5 years. They've already had some large cases about that they've lost. And the reported incidence of violations per year has gone up. It does not decreasing. So these things are revealed, right? Various hacks or abilities to reprogram or different problems, security flaws, and maybe some are fixed and then you get new ones, and maybe some persist for years, even though they're known security problems. Separate from this fact is what we've already said, that your health data is shared and sold from these devices and from many other places, somehow while also complying with HIPAA laws. So you start to get the feeling that these things are happening and we're not really protected. It seems to me a no-brainer. You got a medical device, you got medical records, you got this private stuff. Should it be sold? Yeah, let's have a law against that, because that doesn't seem right. I don't know how much you have to think about it when you meet to make laws, but yet we're not protected. And anonymized data, as I showed, is a fantasy. People can say, well, we anonymize it, so don't worry about it. It's okay, we got this under control. It's not possible. There's no anonymized data. There's no anonymized health data. So we just said that your walking data can identify you, and I pointed out that I think that's really awful. And your phone, every phone now has an app for walking data. Did you ever wonder, like, why? It was like the weather app, which I think a lot of you may have heard is also famously insecure and steals a lot of data while it's serving you the weather that it doesn't need, except, to steal it and resell it. So your phone collects your walking data. Did you turn that off? I turned mine off. But it doesn't matter. It doesn't matter. You can tell me you turned it off. But in fact, they collect it anyway. When you turn it off, what it means is that you don't see it, right? It doesn't mean that they don't see it. They collect it, and it's either in the EUA when you get your phone, because people are going to say no. If I say no, they can't collect it. They can collect it. It's too valuable not to collect. It's something that you can't trace and you can't prove, and they can sell. If you can't protect it yourself and you can never prove that it's been stolen, I guarantee you that someone's taking it. That's just common sense. And it's too easy. It's too valuable and it's too easy. So there's another study. There's tons of these studies that show how you can de-anonymize data, but I liked this particular MIT study, and this is an article, it's not really a research paper, from 2013. Okay, from 2013, which means things have gotten better since then. And what they found in this paper, what did I say?
You said better.
The worse. You know what I mean. It's after 10. So what they found is 4 imprecise data points over a population of 1.5 million individuals allows unique identification of who the data points belong to 95% of the time. And what I liked about this study is that they specifically made the data points imprecise. Now, we'd have to go back to the paper. I actually don't remember what the 4 were. I remember one of them was an insecure location. So they would triangulate the position with the towers, but they didn't use precise location. They used like a radius of several blocks or something. So there's an imprecise location. I think there was imprecise, I don't want to say too much because now I'm guessing, some kind of imprecise medical data and 2 other things. And they specifically designed it to be imprecise, which I think I just said that twice because I found it so impressive. And unique identification of the individuals 95% of the time. And if you made one of the measurements precise, the unique identification percentage went up to almost 99%. So that's how little data you need, how sparse the data can be, and you can still do a unique identification. This is another way that I'm showing that anonymized data, like, forget it. What happens when this device, like the operating system, gets outdated or the company goes out of business, or they just don't feel like updating because they want you to get a new implant? So thank you for bringing that up. And it's something to consider. You get your smartphone every few years, but it's a little harder when it's in your body and under your skin. So, medical device communication, right? I haven't actually said anything about the way that the information is getting on and off these devices except by leakage, as I was saying earlier. So I'm going to start with the little picture on the bottom. It's very simple, and I'm sure a lot of people in the room are already aware of this, but it gives a reality to the devices. So they're very simple, right? They have a microcontroller, and the microcontroller talks to actually 5 things. So there's a sensor, actuators if you have like an artificial arm, and a sensor is what you'd use to collect data. And you could have multiple sensors too. So if it's a defibrillator, you have a sensor that's maybe a pressure sensor or an electrical signal sensor that's telling you how fast the heart is beating, because that's the important information. So what you also have is this information is analog, and I left this off the slide. When you transceive it, it says communication device. It's going to be a transceiver, just a normal transceiver. you're transceiving, you're sending digital data. So you need an analog to digital converter in there. That's going to probably be on the controller. And then what else would you expect, right? You have memory so that you can do management of the data. You can prune it, you can denoise it, you can pre-process it, much like the retina does with the data that it gets. If you have multiple channels coming in, you can fuse it to save bandwidth. Whatever you need done, there might be an AI that makes decisions on the data. You've collected the frequency of the heartbeat, but now you have to know, does it pass a cutoff where it's dangerous and the device has to do something? So there's some decisions that are made on some devices. So that would happen on the controller. So you have the memory for that, right, for the computations, the power supply, the transceiver, and the sensor. And that's pretty much it. It's actually very simple to get this into your body. Oh, I almost left this out. So the communication frequencies that they transmit on are going to be in the ISM band. That would be the industrial, scientific, medical band. And it has many frequencies. The allure of this is that these are, you don't need to be licensed in order to use these frequencies. So you have, this is not in much use right now, but the 173, these are megahertz, 433, I'm sure if you guys are familiar with these. And then the most common is right around a gigahertz, which would be 915, and it's 2.4 gigahertz, I wrote 2,400, or 5 gigahertz. And those are the common bands. You don't need a license, which makes it very easy for the manufacturers. There's Bluetooth communication. It depends on the device, and devices can have multiple antennas. There's Zigbee, which I don't know if people are aware of that, but that's what your appliances use to communicate with the world. And I don't know about any of you, but I don't know why I need to wirelessly communicate with my washing machine and my fridge. And I actually had to get a fridge, our fridge exploded, and right during COVID, so it was sort of a pretty urgent thing. But anyway, I had to go out and get a fridge, and the first thing I did was I opened the grill on the top, and I climbed in there to pull out the wireless antenna, which was on its separate, I mean, you guys, many of you have seen this, right? It was on a separate chip, you just unplug it. And I was very pleased that I was able to find it so quickly, because the manufacturer wouldn't tell me, like, no one would, oh, you can't take that out. Okay, well, you can pull it out. But it turns out also this device was, whatever the one I got was a couple of years old. Now those chips are on the main board. You can't pull them out so easily. If you disable the communication device on your appliances, they won't work. I have a problem with this too. I don't really know how to fix it right now, and that's not what this talk is about, but I'm making you guys aware of this. So, okay, so I'm really cutting it close. They use 1 watt of power or near-field communication. So now I'm going to zip through this. So this is a code. This can be Arduino code. You can go on Hackster.io. That's what that link is to. And this is a high school project, like 9th grade or something. And you can get, and all the instructions on where to buy the pieces are like a Texas Instrument temperature sensor and an Arduino. You put this code in, and you've got a continuous temperature monitoring device for yourself or your cat or whatever you want to monitor the temperature. So this slide basically just says that when companies that do threat intelligence, this particular company, I have to say, it has a global network of sensors and honeypots. They collect 100 terabytes of data per day when they do this information probing to check for security. They found that there was high vulnerability with all personal health information, including medical devices. So I'll skip most of the slide. You can see the numbers. Medical devices were probed and found to be horribly insecure, and they've been shown repeatedly to be insecure, remaining so in 2022. I only picked 2014 because this one was in all the news. This company, Norse and Sens, they do this every year, and the numbers have not gotten any better. But this one was in the news. Interestingly, even though it happens annually and the numbers stay the same, not so newsy anymore. So, and keep in mind, newer medical technology and testing devices, radiological tests, CT scanners, MRI machines, network attached information goes out. Because your doctor might be remote, and he wants to see what your scan is, along with the rest of the world, anyone who can intercept those packets. I'm going to skip this on the DMCA, but I'm just going to say that somehow the DMCA weakens the security on medical devices. Unintended consequence and important. It has important effects on making sure that none of us have really good security. So this is, I think, interesting, and then I'll end after this. These are some unclassified slides. These were classified from 2010. And the reason I find it interesting is before medical devices, before the ubiquity of smartphones. And this is from a series of seminars that was given by the NSA, paid for by your tax dollars, where they were targeting high-value individuals, and they were using the stupidest name I can think of for finding the corpus of your medical information. They called it the medical pattern of life. I don't know why. I think that's really goofy. But the point is that the NSA was interested, and they're a serious organization, right? They're not frivolous. They're not fooling around and having a party, or they're not supposed to be, putting projects together. They're using their signal intelligence to enable what they're calling human intelligence, and they're collecting all the medical information. And I will speed through these. I found these fascinating. And there's a link to these that I can provide. But they define medical intelligence, and look at this last line: medications, medical tests, medical, surgical treatments, hospital and doctor visits. This is before, right, all this electronic health records. You know for sure that's going to be in there, and medical devices, all going to be in these files. That they collect on a high-value individual. Oh, but wait a minute. In 2010, high-value individuals might have been, I don't know, Osama bin Laden, right? But now we're all high-value individuals. Compute power has gotten enormous compared to 2010. The fact is that your medical information has a financial value. That makes each of us a high-value information, and it's so easy to keep it on each individual. Facebook has proven that. Right? We all have a file, and it's very easy to populate it with information. Okay, I hope you guys don't mind. I'm going a little over. So let's see. Did I go backwards? Yes. So, and here's from 2010 again. Here's their picture. So clearly they're anticipating medical devices, and they're showing that they're tiny, they're embeddable, they can be queried covertly. They have accuracy despite harsh signal environments, which I interpreted to mean inside the body. It could also mean if you're going over harsh terrain, I suppose. And at that time, they're talking about RFID, which is very small, short range. But the point is they were anticipating medical devices. So now you have the NSA, who has an interest in this information. To me, that just underscores it's definitely valuable. I mean, we know it, but here's another proof of it. So I'm just going to read the title. Poor security is just a well-known vulnerability. You can see all these quotes and stuff, but I think I've shown it to you. So what about right now in 2022? So I'm going to skip to the second part of this slide. 75, after some studies and quotes from these people and all these other things, 75% of medical Internet of Things devices have known security gaps. This is 2022. And 75%, so I just said this, they have these security gaps. These are related to 40 known vulnerabilities, and 52% remain open to 2 known vulnerabilities with high and critical severity ratings. That are things those are openings that can definitely be used to kill you. And these were first disclosed, those particular ones, 2019. So I guess they're not that worried about it.